So now this video discusses on how we can rationalize the nth roots. So how can we be able to rationalize the nth roots? And let's say we have the nth roots of, should be the nth root of x to the power n. According to the principles behind, you should have to understand that having this case, this is the same as having it as the nth root of, x to the power over n. And of which this is also the same as having it as x to the power 1 over should be n, and it times the power n. So in this case, this n will cancel, or have it as just a single x. And also in the same case, let's say if we have the cube root of, let's say 5 to the power 3. This is the same as having it as, this is the same as having it as 5 to the power 1 over 3 in the overall times 3, that which is the same as 5. And there's something you should have to think about as a way out. Whenever we have, let's say, whenever we have the root, let's say this is the root, and we'll see its root carrier is given as n. And we have, let's say, a term inside with the same power as the carrier of the n, as the carrier of the root. This is the same as x in all cases. And likewise, if we have, let's say, the square of x to the power 2, the carrier of the root, it's 2, and the power of x is 2. Since they are the same, this is the same as x. So that is the principle we use whenever we are to rationalize actually the nth roots at some extent. And let's say if we have the 15th root of, let's say, should be, let's say, 6 to the power 5. Now since the carrier of the root is the same as the power of 6, this is the same as 6 in all cases. So that's how you should have to understand it. And how do we rationalize the nth roots? So before we proceed further, you need to understand another component which is very important whenever we are to rationalize the nth roots. And what is that one? We call it as the conjugate. We call it as what we call it as the conjugate. So if we say a conjugate, it is the reciprocal, or we call it as the reversal entity of a something. That is what we call it as the conjugate. And for instance, let's say if we have, the square of, let's say, x. So what is the conjugate of square of x? Now the point of interest is that looking at the x that we have here, it is under what we call it as the square root, of which the carrier of the square root is given as 2. Of course 2 is silent, not appear there. But what is the power of x? The power of x is given as 1. Now what we need to understand is that we should have to make sure that there is a power 2 instead of power 1, so that we should have 2 here, and with this 2 which is here, then we should be able to make it fine, such that we should have a single x at the end of the day. And for that case, what you have to understand is that the conjugate of this one will also be the same as square root of x. And in the sense that when you multiply the 2, what will happen is that we'll have the square root of x and x to the power 2. In that case, it means this 2 and this root will have it as x. So as you can see, this actual x has no actually a square root, hence rationalization has been done. If we say to rationalize, it means the removal of a side, or should say removal of the root, or whatever aspect. That is how we rationalize. And let's say if we have the cube root of, let's say, m to the power 2. So how do you think we should have to rationalize this? So as you can see, this is the cube root of which m is having power 2. Now to ensure that m is having power 3, we should have to multiply this expression by cube root of m, so that we should have m to the power 3 this side. So hence we'll have to multiply that one by m square, should be cube root of m. In the sense that when we multiply the 2, we'll have the cube root of m to the power m. And hence, as you can see, this will just have the single m there. So take note of that. And how about, let's say, if we have a something like this? Let's say if we have the 4th root of, let's say, x to the power 2, fourth root of x to the power 2, m to the power, let's say, 4 should be, let's say, 3. So how do you think we should have to rationalize this case? So we need to consider each term separately. And we have x squared, and of which the power is given as 2. And we have the root whose value is 4. Now, in order to ensure that there is a power 4 here, we should have to multiply this by fourth root of 2. And there is m to the power 3 here, of which the root is of root 4. That is the carrier. Now, to ensure that m is having 4, we should have to multiply this one by m, actually fourth root of m. So in that case, we'll have it as the fourth root of x to the power 2 and that times m. If we multiply the 2, we'll have it as the fourth root of x to the power 4 and m to the power 4. So in this case, this is the same as having it as xm. So that's how we have to understand about the rationalization like that. And what if, let's say, we have something like this? Let's say if we have the 16th root of x to the power, let's say, 8, and y to the power, let's say, 10, and let's say a to the power should be 5. So how do you think we should have to rationalize this case? So as you can see, this is the root was carrier 6, and but we have x to the power 8, and y to the power 10, and a to the power 5. So how should we have to ensure that all these are having power 6? So in this case, we should have to multiply this one by x to the power, and that should be negative 2. And we should have to multiply this one by y to the power should be 4, actually negative, should be 4. And we should have to multiply this one by a to the power 1. So to ensure that all will have the power 6. So in this case, we'll have it as the 16th root of x to the power, and that should be negative 2. And the y to the power should be negative 4. And the a to the power 1. So if we multiply the 2, we'll have it as the 16th root of, x, 8 minus 2, and y 10 to the power should be 4, and we'll have it as a to the power 1 plus 5. Mind you, we're using the laws of indices here, and such that the bases are the same, just have to add the powers. So have the 16th root of x to the power 6, y to the power 6, and a to the power 6. If that is the case, then it means we'll have it as x, y, a. So this is how we should have to understand about the rationalization. And how about, let's say, if we have this kind of a case, and appreciate how we can have it. And let's say we have the 9th root of, let's say, m to the power 7, and x to the power 15, and let's say c to the power 12. How should you have to rationalize this one? In other words, how should you have to remove the 9th root if that is the case? So now principle means the same. Or have to have the conjugate of this. Well, that would be given as m to the power should be 2, and our x to the power should be negative. That is should be 6, and c to the power should be negative 3. Now in this case, we'll have it as, let's say, the 9th root of m to the power 9, and x to the power 9, and c to the power 9 as well. That will be given as mx should be c. So that's how we rationalize that one in that case. And what if, let's say, we have this case? Let's say we have a square root of x, let's say minus 1. So what is the conjugate of this case? Now the conjugate of this expression is equal to x and plus 1. So that is the conjugate, in such that should be this. The conjugate of this expression is given as the square root of x and plus 1. In such that, let's think of multiplying the 2. We'll have it as the square root of x plus 1. So just have to change the sign. If it is positive, we'll have it as a negative. If it is negative, it will be positive. So in this case, x is square, actually square root of x, square root of x, we have it as square root of x squared. And the square root of x times 1, that is square root of x minus the square root of x and that plus 1, of which this is x and this is L, and we have plus 1. So as you can see, the square roots has been eliminated there. So if we have, let's say we have the square root of x and the plus, let's say, square root of 2. So what is the conjugate of this? Now the conjugate will be given as the square root of x and the minus the square root of 2. We just have to actually change the sign. Now in this case we'll have it as, so try to multiply the 2 and see whether the roots will be eliminated or not. And what if we have, let's say this case, let's say we have the square root of, let's say, x plus 1, and let's say like that. So what is the conjugate of this expression? So since all these terms are inside the root, then the conjugate is the same as the square root of x plus 1. So there is no need that the sign should change. The sign should just have to remain the same. The sign is only said to be changing if it is connecting two separate aspects. And what if we have, let's say, the square root of m plus 1 minus the square root of, let's say, 2m minus 5? So how do you think we should have the conjugate here? Now the conjugate of this, actually of this expression, will be such that we'll have a positive here, but the signs inside will be the same. Then try to multiply and see whether the roots will be eliminated or not in that way. And also try to have the conjugate of the following. Let's say if we have 5 minus 2 times the square root of, let's say, 5x. And what if we have, let's say, 2 plus, let's say, square root of 4 minus x, like that. And we should also have the nth roots of, let's say, we should also have to have the conjugate of, let's say, -1 plus 5 square root of, let's say, y. You should have to rationalize that one as well. And let's say if we have, there should be xy minus the square root of, let's say, m to the power, let's say, should be 5. So try to have those out at your own time. And what if we have the cube root? Let's say if we have the cube root of, let's say, x, and we have plus the cube root of, let's say, y. How do you think we should have the conjugate of this and be able to rationalize? Should we say we'll have to change the sign in order to have the conjugate of that one? And of course, you may think of having it in that way, but try to verify whether it will be the same way or have to do it here or not. So here is the thing you have to understand. Whenever we have the sum of two cube roots like this, or whenever we have the difference of two cube roots, let's say like this, let me have the difference of two cube roots like this, we need to understand about the following principles when we are to come up with the conjugates of this. So let's think about this. We should have to understand that if we have the sum of two cubes, let's say we have a to the power 3 plus b to the power 3. How do we rationalize this one? Now I should say, how do we factorize this one? So the factorized part of this expression will be given as a plus b, and times, a square minus ab, and plus b square. And likewise, we have the difference of two cubes. Let's say a to the power 3 minus b to the power 3. The factorized part of this expression will be a minus b, and the times a square, and that of plus ab, and plus actually a b square like that. So you need to understand this. So whenever we are to factorize the sum of two cubes, this is the expression, or that is the formula. And whenever we are to factorize the difference of two cubes, this is the formula. And for instance, let's say if we have x to the power 3 minus 2 to the power 3. Now how should you have to rationalize, actually how should you have to factorize this one? This is the same as having it as x minus 2 like that, and times x squared minus 2x and plus 2 to the power should be 2, that is given as 4. We'll have that one. And let's say if we have, let's say m to the power 3 minus, let's say 5 to the power 3. Now how should you have to factorize this one? We'll have it as m minus should be 5, and the terms should be m squared, and the minus 5m and a plus 25. We'll have it as that. And likewise, let's say if we have, and that should be r to the power 3 and a plus q to the power 3. This is the same as having it as r plus q and that times r square, and that should be, we should have a plus here. By the way, we should have plus and a sort of plus here. And we'll have it as minus, we should have it as rq plus q square, according to the formulas that we have presented here. And more about actually factorization that involves the difference of two cubes, and that of actually a sum of two cubes, you should have to refer to my previous video. I explained about factorization techniques, of which the comment will be posted, of which the link will be posted in the comment section below. So try to follow that one up. And now we understand that if we have a sum of two cubes like that, the factorized part is given as this. Now in this case, this part is said to be the conjugate of this, and this part is said to be the conjugate of this. I want you to understand it in the same way. This is actually a part, its conjugate is this, and this part, its conjugate is this. So that's how you have to take it like that. And now let's say we have the cube root of a plus the cube root of b. Let's say that is the case. If you can clearly depict this to be a sort of sum of two cubes, if you think of trying to look at this the way it is like this, although these two although this expression, it is not much about the power 3 sort of, but if we can think of looking at it as in the same way it is like this, here is what you have to understand. The conjugate of this expression will be given as this expression. That will be given as a square minus ab plus b square. That will be the conjugate. And likewise, if we have the difference of two cube roots, the conjugate of that one will be this. That will be given as a square plus ab plus b square. So that's how you have to understand that one. So here is what you have to keep in mind. The conjugate of cube root of a plus the cube root of b is given as a square minus ab plus b square, as we have it here. And the conjugate of cube root of a minus cube root of b it is given as that of a square plus ab plus b square. So make sure you understand all these things and are in those cases like that. Let's say we have something like this. Of course, this piece of information seems to be not making such sense, but for this case you'll be able to understand what it means there. Let's say if we have the cube root of, let's say, m plus the cube root of, let's say, n, if that is the case. So what is the conjugate of this expression if that is the case? Now, first thing, we should have to let the first part to be, let's say, x. So have it as, the cube root of m, like that. And we should have to let the second part to be y, or have it as the cube root of n, should be that. So at the end of the day, you can see that having x plus y, it is the same as having it as, cube root of m plus the cube root of n. If you can see it clear, because we have actually expressed that x should be equal to this and y to be equal to that one. If that is the case, then the summation of this, it is the same as that, which is the same as that. So keep that in mind. Now, the conjugate of this expression, which is this, will be given as the conjugate will be given as, now since we have the sum of two cubes, the conjugate will be given as x squared and minus xy and plus y squared, and of which, if we substitute those, we'll have it as the cube root of m and to the power 2 and minus the cube root of m times the cube root of n and plus the cube root of n to the power 2, that is, and of which this is the same as the cube root of m to the power 2 and minus the cube root of and minus the cube root of ab, actually mn, and plus the cube root of n to the power 2. So this is the conjugate of this actually expression. And what if, let's say, we have the cube root of, let's say, should be the cube root of a minus the cube root of b. So how do you think we should have the conjugate of that? The principle remains the same. We should have to let x being equal to the first part, which is cube root of a, and we should have y being equal to the second part, which is the cube root of b. And of which, keep in mind that x plus y, it is the same as, should be x minus y rather, should be x minus y. It is the same as having it as the cube root of a minus the cube root of b. It is the same as that. And of which the conjugate, and since we have a difference of two cube roots, the conjugate is given as, should be x squared and plus ax, should be plus xy rather, should be xy and plus y squared, and of which that will be given as, that is cube root of a to the power 2 and plus the cube root of ab and plus the cube root of b to the power 2, and of which this is the same as the cube root of a to the power 2 plus the cube root of AB and then plus the cube root of b square, like that. So that is the conjugate of that expression. And as you can see there. And what if, let's say, we have the cube root of, let's say, x plus 1 and minus the cube root of, let's say, x plus 5. So how do you think can be the conjugate of this? So try to have that. And also try to deduce the conjugates of the following. Let's say cube root of m actually plus 1 minus, let's say, the cube root of, let's say, 5m. What would be that one? And let's say we have the case where we have the cube root of, let's say, it should be AB and that plus the cube root of, let's say, xy. So try to have that. And let's say if we have the cube root of should be n plus the cube root of, let's say, m. So how do you think we can rationalize that? So try to have the conjugate of those and also try to rationalize and that to see if really possible that they actually roots are eliminated. So thank you, and don't forget to subscribe to my YouTube channel as well as the TikTok page, and for you to keep on being updated on whatever the content that has been created. And for our physical and the online classes, don't forget to contact this number, which is 09727 2626. So that's how you should have it.